All right, today we will be talking about proportionality theorems. Our objective is that we will be able to use proportionality theorems with triangles and parallel lines to calculate line segments. So in our first example, if our goal is in the diagram AB is parallel to CD, BD equals 15, AC equals 10, and CE equals 18, find DE. To answer this question, we must know the triangle proportionality theorem. This theorem says if a line is parallel to one side of a triangle and intersects the other sides, then it divides the sides proportionally. So we were told that BD is 15, AC is 10, CE is 18, and since DE is what we're trying to find, I'm going to label that as X. So since it's proportional, this parallel line that's parallel to the bottom of the triangle splits this up proportionally. So BD over AC would have to equal DE over CE. So top to bottom, top to bottom, top to bottom, top to bottom. Smaller pieces, bigger pieces. Or if we wanted to, we could say piece on the left on the top, piece on the bottom on the top. Or sorry, piece on the right on the top. So BD over DE would have to equal bottom left piece over bottom right piece. Both of those proportions will give you the same answer in the end. So I'm going to use the top one and fill in what we know. BD was 15 over AC, which is 10, equals DE, which is X, over CE, which is 18. And just like we've been doing for this whole unit, we're going to cross multiply. So 15 times 18 equals 10 times X. So 270 equals 10X. Divide both sides by 10, and we get that X equals 27. If in the diagram PQ divides lines LN and MN into the length shown, determine if PQ is parallel to LM. So we want to know if this segment that cuts our triangle into two pieces if it's parallel to the top of the triangle. So to answer this question, we must know the converse of the triangle proportionality theorem. Think back to the beginning of the year with our if-then conditional statements. Converse, like the shoes help you move. Converse is where you move the hypothesis and the conclusion. So the order switches. So if the sides are divided proportionally, then the line dividing will be parallel to the triangle's side. So if LP over PN equals MQ over QN, then we know that PQ and LM are parallel. So let's plug in the information we were given. 18 for LP, PN is 16. What does that simplify to? Simplifies to 9 over 8. I'm going to put a question mark back here just so we're saying we're questioning, are they equal? So then we would also check MQ is 27, QN is 24. That also simplifies to 9 over 8. So yes, PQ is parallel to LM. Our next type of problem and our next theorem, use the figure to complete the following proportions given that BC is parallel to DE, which is parallel to FG. To answer this question, we must know the three parallel lines theorem. If three parallel lines, which we have, intersect two transversals, so that would be line AF and line AG, then they divide the transversals proportionally. So if BD is over DF is equal to something over EG. So EG is on the bottom with DF. So it's right there. Those two, we go from top to bottom straight across. So whatever's going to go with BD would have to be, that's the top, the bottom is CE, and it's straight across from it. What about AB, right there, over AF, so this really long piece. So from A to F, then BC, so we're looking at I'm going to highlight it, this smaller triangle here, as well as the big triangle of it all. So AB was the small side, AF is the long side, BC was the bottom. So for the bottom of our denominator here, we want the bottom of the big triangle, which would be FG. I now want you to try the picture and try to fill in these four proportions here. Pause the video to try it and then check back for your answers. How'd you do? Did you get them all right? Let's move on to our next theorem. Our goal is to solve for the missing side length x. So to answer this question, we must know the triangle angle bisector proportionality theorem. If a line or a ray or a line segment bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other sides. So we know that this segment cuts angle C in half because these two smaller angles have the same markings. Therefore, we know that AD over BD will be proportional to AC over BC. So 3 over x will equal 9 over 12. You can cross multiply, which would give you 36 equals 9x, and then divide both sides by 9 to get that x equals 4. Or you may have noticed, to go from 3 to 9, I would have to multiply by 3. So what number would I multiply 3 by to get to 12? X must be 4 then. Let's use this theorem one more time to solve for the missing side length x. So before we start, we don't know exactly what the length of TR is, but we know that from P to R is 8, and this piece is x. So that means T to R must be 8 minus x. Now we can set up our proportion. PT over TR is going to equal MP over MR. X over 8 minus x will equal 3 over 9. Now, how did I know that the 3 went on top and the 9 went on the bottom? If you look at these pieces, x is the piece smaller than 8 minus x. So the 3 and the x must line up because they're both small. 8 minus x and 9 both line up because they're longer. Now we're going to cross multiply. 9 times x is going to equal 3 times 8 minus x. 9x equals 24 minus 3x. Add 3x to get our like terms together. 12x equals 24, so x is 2. In your summary, write about the different ways you can set up your proportions. That's all for today. We'll